The question here is from the chapter Relations and Functions, where they are asking us to find the range of this given function, and it is defined from r minus 26 to all the real numbers, and it is given as x square plus 2x plus 1 by x square minus 8x plus 12. So to find the range, let us start with writing it as y is equal to x square plus 2x plus 1 by x square minus 8x plus 12. My objective is to make this in terms of an equation which contains x square, x and a constant, so that it will be a quadratic equation. So when I cross multiply, I will get yx square minus 8xy plus 12y equals x square plus 2x plus 1. And when you take this x square to the left side and take it common, you will be having y minus 1. When you take this 2x and take it common, you will be getting plus x, and then you have minus 8y minus 2 plus 12y minus 1 equal to 0. So this is what you get as a quadratic equation. Now, when you look at this quadratic equation, which is in terms of x, you know that x is defined from real number minus 2, 6 to all the real numbers. So that means the value of x is always going to be a real number. So if the value of x is going to be a real number, and here we have an equation in a quadratic equation in x, the discriminant of that particular quadratic equation should be greater than or equal to 0, or it should be giving us a real value. So this discriminant here should be definitely greater than or equal to 0. And what is the discriminant? B square. This is b, and this is a, and this is c. And when you use all these things, we will be getting it as minus 8y minus 2 the whole square minus 4 into y minus 1, that is a, into 12y minus 1. Okay, this should be definitely greater than or equal to 0. So when you do the calculation, 64y square plus 4 plus 32y minus 4 into 12y square minus 13y plus 12 plus 1 greater than or equal to 0. And when you take it inside, you will be getting it as 64y square plus 4 plus 32y minus 48y square minus 52 plus 52y minus 4 greater than or equal to 0. And from this, can we cancel 4 and minus 4? Yes. 64y square minus 48y square, that is going to be 16y square. 32y plus 52y is going to be 84y. This is greater than or equal to 0. And from this, can I take 4y common, and I will be getting y plus 21. What y? Not simply y, it is 4y plus 21. Okay. This is going to be definitely greater than or equal to 0. Now you have an inequality, and you know that when there is an inequality with greater than or equal to 0, we can write what is 4y. When you substitute 4y, you will be getting y 0. And when you substitute 4y plus 21, you should be getting it as minus 21 by 4. So now we can write the solution of this linear inequality as, because you have minus 21 by 4, it will be minus infinity minus 21 by 4 closed interval. And then you have 0 here, right? So that will be 0 to infinity, closed at 0, and the union of these two. Okay, so this is what we got. Now look here, this discriminant is greater than or equal to 0 only when you take y not equal to 1, right? Only when the y is not equal to 1. If y is equal to 1, then this discriminant we cannot take that discriminant like that. Okay, so when y is not equal to 1, we can take it like this. Now, if y is equal to 1, what will be the value? We know that x square plus 2x plus 1 by x square minus 8x plus 12 equal to y. So I'm giving it as 1. So from that, I will be getting x square plus 2x plus 1 is equal to x square minus 8x plus 12. X square cancelled. I will be getting 10x is equal to 11, or x is equal to 11 by 10. So now, why did we do this is because you can see that if I give y is equal to 1, I am getting x is equal to 11 by 10. My domain here is 2 minus r minus 2, 6. Is this 11 by 10 included in any of that? Yes, it is definitely included in this domain itself. It is not outside the domain. So that means when y is equal to 1, that is the output. When y is equal to 1, the output, we are just suggesting, or when we are putting it as a trial, we are getting the input that for that particular output as what? 11 by 10, which is included in our domain. So therefore, our answer we can write directly as minus infinity minus 21 by 4 union 0 to infinity. Clear?